Okay, we continue. Function pointers. Before that, we already learned that pointer variable can hold address for another variable. So if I have variable x, I can have pointer ptr, and it's hold, for example, if this x have address 1000, it will hold the pointer, will hold the address. This means it's pointing to this variable. Similar also, function pointer also is a pointer that point to function. Why? Because function itself, it's really like any variable. It have a starting address in the memory, because when we mentioned that function will be in the stack and it will have a frame in the stack. So this frame in the stack actually will have a starting address. So you have a starting address in the memory for the function, for everything inside this function. Yes. And how to reach this address? By the function name. So actually function name, it's like any variable have the starting address in the memory for this function. So you can have pointer to have this address, for example, 1000 the starting address, and you put in this pointer ptr this address, so it start to point to the function. So we can have pointer also to point for a function. How to define this type of pointer? To define this type of pointer, we give the pointer name. You can name it X, Y, Z, anything, or FBTR or BTR. But to know it's a function pointer for the compiler, it will have data type and it will have this brackets and the star, and here the passing parameter. This means this pointer will point to the function that have two passing parameter from type integer. So if I have function x, later I can mention that f btr equal x. This means this pointer will point to this function. Okay, then it's working like this. Here in this example, I have three functions. Function to take two integer and give you the summation. The second function to give you the minus or subtraction or minus for this two variables or two passing parameter. Then another function to make multiplication, to return or to print multiplication. So I just define three normal function like any function. Now in my main function, we define here a pointer. I called it fun pointer. It's actually, if you look here, it's from type function pointer. So the compiler know now that this pointer fun pointer will point to a function, and this function that will be pointed by this pointer, it will have two integer passing parameter, and the return value of this function void. So here you define the type of the function, and here you define the passing parameter of the function, or of the pointed function. Here I define only normal variables a, and give initial value 15, and b, and give initial value 10. Then I ask the user to enter his choice, what function he need. He need to add, he will enter 0 if he need minus, enter 2 if he need multiply, enter minus, enter 1, multiply, enter 2. Then here I need this all, it's normal, yeah, just give it choices for the user and read his choice. Here I have if statement to check, if else statement to check what choice for the user. If he chose add, then I will make this pointer. So we have pointer now, and we have stack like this. Of course, the pointer in the stack, in another area in the stack, okay? We have stack like this. We have functions, or we have memory addresses for each function. Okay, address, for example, 1000, 2000, and 3000. It's just just suppose it's like you imagine like this. When we define this pointer, it's empty at the beginning. Now we said that f pointer equal add. This means f pointer, if the user chooses this one, f pointer will take the address of add. If the user choose 2, we assign the address, the starting address of this function to the pointer. If the user choose 2, we assign the starting address of multiply to. Then it's depend on the user choose choice here. For example, he chose 1, then the address will be here 2000. It will point here. So now we have pointer pointed to this function. Okay, then I can use the pointer like this. Pointer and passing parameter. It's same like if I called this function. It's equivalent to call the function directly, subtract with passing parameter. Why I need this type of pointer for functions? Because sometimes I need to have choices in the function, run different function depending on the user choice, and I don't want to write it every time totally. For example, sometimes you have functions for sorting. For example, you need to sort, for example, ascending or descending. Okay, so in these cases, you need to have some choices to give different address to the pointer, then you will run using the same here, using the same sentence, we run different type of functions. So if user choose 0, the address will be for the function add, then this means run add function. If user choose 1, then the address will be for subtract function. Then it's same, you see, the same sentence will run different function depending on which address, which function we assigned for this pointer. So this function pointer, I think the name. Okay, then we just define or build 3 function to print the add or subtract or multiply, then ask the user to choose which operation he will do. Depending on the operation, we will assign the address of the function to the pointer. Then here we just use the pointer to call the function. This calling the choose. I'm not sure about the spelling. I think it should be okay. Choosing later I will see what about the spelling. Call the choosing function. Then here just calling the function. Someone will ask, I did not put the function name here. How to call it? It depends on the address. I'm calling the pointer like calling the function. It's similar like when we make pointer for array, we can use it as array. Here similar, it's pointer for function, I can use it like calling a function. So if you choose, for example, 0, then you will add the numbers. If you choose 1, then you will subtract. Then if you choose 2, it's multiply. Okay. Then we finished here everything about pointers. Now we will have some examples. In example 1, write a program that continuously. So we need program to continuously ask a character unless user press enter, and print star for each character. Okay, let now just understand what we need. We need to read from the user. He will still enter character until press enter. So we can have while loop, okay, until he enter. This while loop will continue until he enter the enter button, or he press the enter button. So we can here make if statement. If the button is enter, then we can make a break for this loop. Then later we can even print this entered character. Okay, where to store these characters? If I need to read characters until I press enter, where to store these characters? I can store it in array. So we need array from character type. We can name it, for example, ch. Then we have to give size, for example, 100 or something like this. Okay, how to check the enter button? Actually, the character code for enter is 13, so we can just check the character code. So now this first version, okay, we define array with 50 or even 100 or something like this. Then we have pointer, and this pointer pointed to the array, and we define here just counter, okay, to count the characters. Then while one, this mean infinite loop, okay. Then we give value for the pointers. This means for the array, for the pointed here, pointer will point to the first element of the array, as we mentioned before. Then pointer p will point to the first element. bi, this means we will move one by one. This means next time we'll point to the next element, the next element, the next element, and so on. Then to get the values here, or to change the value, we will use star. It's like revision, this examples for the pointers. Okay, we already take this. So get here to get character or read character by character, and we start this character in the array one by one. Okay, if the entered character equal 13, then break. Why? Because it's enter button. If not, we will just print put characters. This means put character on the screen. So if you enter, it's good for password, okay, applications and any. So when you write on the screen here, what you write will not appear on the screen when you use Getch. So that's why we put what? We put the star every time you write. You like writing a password, you will write stars. Okay. Now here, just printing the elements and then plus, or move to the next one. The main issue here, okay, here normally printing for loop from 0 until reaching the last element, and just normal printing. Here's the issues that I have to mention. Here it's static, not the static variable. I mean automatic, not the static. It's the correct term. It's automatic definition. This means we define this array as automatic. It will be stored in the stack, and it's limited to 50 to 100. What if the user enter more characters than 50? it will not be stored here. You will reach the limit of the array. But here, if you look to the question, continuously take character. We did not specify any size. We said until press enter. So it's not correct to have size here because we need the limit to be until press enter. Then without dynamic memory allocated or allocating, it will be limited. I need it unlimited, then I have to do dynamic memory allocating. So the next version for the same example, it's using dynamic memory allocating. We don't need to define array as before. We define pointer, and this pointer will point to the part from the heap. The size we will put here. At the beginning, we start with character size, 1 character size. So we read same like before, and we check if it's enter, then a break. If not, then we will print star in the screen. Now, every time you reach here, we make reallocate to make the size a +1. So we are, every time we add to the location another character size, decrease the size. Okay, every time we decrease the size. So the new size of B will be 2, 3, 4, 5, until you make here a break, then you can go and read character 1 by 1. It's same here, except we don't need array. We can use this pointer and we dynamically locating it. At the beginning, we give it size 1 character, but every time we read more character, we increase the size. Now it's fully dynamic, and the user can enter as much character as he wants. Of course, until the physical memory full, and I think it will not full very easy, become full very easy from only characters. So this first example 1, PTR example 1. This is a correct answer, yes? Just to mention, this is not correct answer for this example. Why? Because it's limited. So this example shows you the importance of heap and dynamic memory allocating, so you can have dynamic size for this array. So it's like this here. Now we make memory allocation and we get character by character. Every time you get character, it will write star. Okay. It writes star, but in the variable, it's stored as characters. Okay, then enter. This characters that I entered until press enter. So this is the answer for first example. Then which answer correct? This answer, the correct one, because it's unlimited size here. Okay, this example said, write a function prototype, give below which interchange two variables value. So if you have variable x and variable y, and you have 5 here and 10 here, how to change the value of these two variables? How to get this one here and this one here, the value? Actually, to make like this, you cannot make it directly. If you said x equal y, then x will become 10. Then where is the value of y, previous value of x? If you said y equal x, it's same issue. So to make this interchange or swap, we called it, you need here another variable, for example, z. So you can now make like this. You can put x here. So you can set z equal x. Now z will have 5. Then you can put y in x. So now you mention that x equal y. Then you can put z here. This become 10. So you can put now z on y. This means y equals z, which is 5. Now we made a swap. Now x become 10 and y become 5. So we will have function called swap, and this swap will take two integers. Why we make this two passing parameter as pointers? Because if you remember, before that, we said that return value give us one value. But from the swap function, we need two values. We need value of x and value of y. Yes. Also, maybe we need to keep the original value of x and y. X and y will be defined in the main function. This function is swap only to swap the values, but we need to use it outside it. So instead of use x and y in the swap function, we will use the address. We will use the pointer. So we need b for x and b2, for example, as pointer for y. Now, if you make the swap, you will have the data inside x and y, because this passing by reference. Okay, we already take passing by reference. That's why we passed by reference, because we need to use these values outside the function, actually inside the main function here. So we have 2 or even 4. Here in this example, we make the swap 2 times. 2 times. First time swapping x and y, second time swapping a and b. So if we print a, b, x, y, first time before the swap, it will be 10, 2, 3, 5. After swapping x with y and a with b, the output will be 2, 10, 0.53. Yes. So why we used pointers as passing parameter? Because we need to pass these variables by reference, because we need to keep it outside the function, outside the swap function. We need to keep the values. That's why we pass the address, or we pass by reference. Okay, we already take pass by reference. So this is example for the swap, example 2. Okay, I can remove this 2 parts now. Later I just make a swap between 2 variables. This is what I'm changing now to focus only here. Then we have here the swap function. In the swap function, we take 2 reference for 2 integer variables. Now we put the first value inside temp. Then first value will be we will assign second value to the first value, and temp value, which was the old value of P, to a Q. Now we, like this, we made swap. Swap very important actually in programming. It's needed in too many algorithms usually use swap. Okay, like sorting algorithms usually use swap to change items inside the array to make a reorder for it. Okay, and here it's just simply we print the previous value and then make a swap. Of course, we pass by reference here. We pass the addresses for the swap function. Then we check the value after make swap. So the value before make a swap, sorry, this because we printed more than 2 variables here. So the value before the swap 10 and 2, after the swap 2 and 10. Okay, so swap, it's really simple, but the issue here, when to use passing by reference. So previous example, it's about dynamic location. This example, it's about passing by reference, or call by reference. Okay, this example, example 3, we just have this example and another example, and we can finish early, inshallah. This example for a function prototype which calculates the area and perimeter of rectangle. Area of rectangle, for example, if we have rectangle X and Y, the length and the width of it. So the area will be X multiplied by Y, and the perimeter will be X plus Y multiplied by 2. So here it's similar to a previous example, and we take example like this before, that we need to return two values, the area and the perimeter. That's why we will use also passing by reference. So we need these two parameters of this function as pointers, and we can pass, or sorry, here we can pass the value by reference to take the new value. Here, initial value by reference, this function will return the calculated value. So we just read here X and Y. This means we read the length and the width of the rectangle. Then we call this function by reference, X and Y by value, because we just give the length and the width. It will not be changed inside the function. What will be changed and give me the result? The area and the perimeter. That's why we pass by reference. So now inside the function, we calculate the area and perimeter. And you have to focus here. We use the asterisk here, or this star, to mention that this two parameter, it's pointer, and we need to change the value of these two variables. So this is the area and this perimeter. This example, write a function that perform like strlen function. This means we need to give this function a string or array of character, okay, or pointer for array of character, and it will return the length. So here we define array, then we read the string. We can use this one, get s or get the string. It's a function in the library conio. It's to read the string, so you don't need here to give character by character. It can read the array of string or string directly. Okay. Now we print the length of this string using our function. This our function. It's defined here. The keyword function in std input output. It's small letter all. Here we define it with S small letter, capital letter, and L capital letter. We just take the pointer for this string character, and then we check if we reach the end. You book like this, and you read the string, for example, strx. Then when you finish, last one will, or the remain will be like this. So we read one by one until we reach the end of the data. So we have counter to count, this n to count, and this b plus plus for the pointer b to move one by one. Okay, here for move of the pointer, here for the counter. Then we return the counter. So the return value from here will be the number of character or the length of this string. Let me run this code This example 4. You just enter characters. This one, I think 11 or 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. Of course, the space will be stored as character in the array. Okay, that's all for pointers. We finished pointers. We give examples here. So, anyone have a question here before we end this lecture? So I feel my sound today like tired because okay, inshallah